Number 7. So here's a polygon, A, B, C, D. Your job was to draw dilation of ABCD using center B and a scale factor of 2. So non-negotiables. You have to start at center B, which is right here. You cannot start anywhere else. That's where everything is going to be touching. The scale factor has to be 2. So right now you should be thinking, is that getting bigger or smaller? It is for sure going to get 2 times bigger. Okay, then it says label this dilation as figure F. Okay, well we know with our straight edge, and I don't have one at my house right now, but I'm just going to use this picture. I can extend every line or every point connected to the center, and my answers have to be on these lines. Okay, they are rays that we are creating. If your point is not on these lines, your shape is wrong. End of story. Okay, so if I get 2 times bigger, hard thing, well, the easiest one is A, because that's on a line. So let's count. 1, 2, 3, 4, 5, 6, 7 boxes. Well, 7 times 2. Now I need to go 14. So 7 more. 1, 2, 3, 4, 5, 6, 7. All right. A prime. Great. That one's easy. Now D and C are not as easy because they're not nicely on the grid. So we need to count their distances and change those by a scale factor of 2. So I went over 1, up 4 to get to C. So instead of going over 1, I need to do 1 times 2, and now I go over 2. Now instead of going up 4, I do 4 times 2, I have to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And look how it nicely lands on the line. This is C prime. All right, so now I know C and D are on the same line. That was where they originally were, so it's going to be the same in my picture. So if I go back up here and I just come on the line, their distance before was 2. 2 times 2 is 4. 1, 2, 3, 4. Same height on the line, 4 apart. So using your ruler, you're going to connect those. Okay, then I'm going to use my ruler, or my straight edge in this matter, and connect, line it up a little bit better, A and D. A lot of you did a really nice job getting the bigger shape. Okay, and this is figure F. Okay, that's all you had to do for A. For B, you need to now draw a dilation from ABCD. So we go back to the original shape, but this time we use center B, but our scale factor is 1/3. So you should be thinking about 1/3. Is that shrinking my shape or making it bigger? Oh, it's going to be smaller, because anything less than 1 shrinks my shape. Okay, and this needs to be figure G. So again, I know wherever I draw my points, they have to be on these lines. If you didn't use a ruler, a lot of you drew your shape incorrectly and you got points off for that. It has to look like the original. That's the whole point of similar shapes. So I was a little picky on that. Okay? All right, so 1/3. And a lot of you are like, 1/3? It grew, but it was 4. And now I'm going to use 1/3? That's not fair. Yeah, I didn't give you a very nice number. Sorry about it. So instead of going over 1, now I think, well, what's 1 times 1/3? Because we always multiply by our scale factor. That's 1/3. So I only go over 1/3 of a box. Okay, then I've got 4 high. 4 times 1/3, that's 4/3. Or I can think about 1 and 1/3. Okay, so over 1/3, up 1 box, up about 1/3 of a box. Notice I'm still on the ray. Okay, this is C double prime. Okay, for D, I know they have to be on the same line, the same distance high, because they were originally. So I can just come across and put D double prime. If you wanted to count, though, you totally could. It's the same thing, though. Over 1, up 4. So over 1/3, up 1 and 1/3. So now I already have 2 of my points. Then I had a distance of 7. Well, 7 times 1/3 is 7/3, or 2 and 1/3. So 2 boxes, and a little bit past the second box. Still on the line, as I should be. Now with my straight edge, I'm going to connect the shape. Notice how my lines are nice and clean. These all look identical. Now they're not the same in their size, but their shapes look identical. All right, Then, show that figure F and G are similar. So this goes back to like the first page where you had to prove some similarities. Well, you know all angles are the same because they're all scale factors of the original. Okay, but that's not enough information. You also need to prove the sides. So that being said, I'm going to figure out, and I didn't label this one very well, figure G. You need to figure out what is the scale factor from figure F to figure G, or figure G to figure F. I don't care which way you went, but it does change your scale factor. So let's do G to F, from small to big. So my answer should be bigger than 1. So I'm going to say scale factor from figure G to F is, and now I need to figure it out. Well, this side's probably going to be the easiest. I know that this is 2 1/3. I know that this one is 14, right here. And if I'm going from small to big, I can do 14 divided by 2/3. When I do that, I get about 6. That's all I needed. But you had to say something about a scale factor. If you went the other way, if you said, okay, well, actually, Miss Grew, I did figure F to G. Well, what is that scale factor? It's just the reciprocal. So instead of 6, I'm now shrinking it by a 6. So it's going to be 6 times smaller instead of 6 times bigger. So I took either of these to be correct. If you have questions, let me know.